Hello class, this is lesson 4-4 about transformations of linear functions. There's different types of transformations that maybe you've learned about. The first is called a translation, and in our lesson, this is when we will move a line up or down, or we might move it left or right, okay? A dilation is different. It's not going to look like the same line anymore. And this is where we are going to stretch or we are going to compress the line. So it's going to look like it is more steep or like it is less steep, okay? And then the last transformation that we're going to perform is called a reflection. And this is where we're going to take our original line and we're going to flip it across either the x-axis or the y-axis. But all of this is based on the parent linear function, which is f of x is equal to x. So if I was going to graph this, I can choose any points, and every single time the x value and the y value are the same. So I can plot all 5 of those points there, draw my line, and as you can see, the parent linear function goes straight through the origin with a slope of 1. So let's go ahead and check out our first transformation, which is a vertical translation. So this means that we are going to see a constant, we'll call it k, that is going to be added to the parent linear function, f of x. And when we add it, it's going to move that parent function, that line, either up or it's going to move it down. So for my first one, I'm going to go ahead and graph the parent linear function. And then we're going to graph g of x. This time, g of x is equal to x plus 2. And so I'm going to go ahead and choose 3 points, -2, 0, and 1. And when I plug it in, -2 plus 2 is 0, 0 plus 2 is 2, and 1 plus 2 is 3. So now let's go ahead and plot those 3 points and use my ruler to draw the line going through them. And as you can see, I took that parent linear function and I just moved it up 2 units. So to describe this translation, all I need to say is that g of x translated the parent function up 2 units. And that's it. Let's go ahead and do another one. Let's graph the parent function. And then this time I'm going to choose those same values, -2, 0, and 1, and I'm going to plug them in. So that's -5, -3, and -2. And now I can plot all 3 of those points and draw my line, connecting them. And as you can see, the parent linear function now has just moved down 3 units. So I can write g of x translated the parent function down 3 units. And that's it. So now let's go ahead and move on to a horizontal translation. And it's going to look very similar to you. This time there's going to be a constant h that is going to be subtracted from any of the x values that are in the function f of x. Okay. And when we subtract these values, then it's going to be moving the function either to the left or to the right. So like we did before, let's go ahead and graph the parent linear function. And now I can go ahead and draw my table and choose those same values, -2, 0, and 1. -2 plus 3 is 1, 0 plus 3 is 3, and 1 plus 3 is 4. So I can go ahead and plot all 3 of those points and draw my line. And it looks kind of similar to what we did before, but this time we're focused on how it moved horizontally. So it moved to the left 3 units, and that's what we're going to write. So g of x translated the parent linear function 3 units to the left, or I could say left 3 units. And we're done. All right, let's go ahead and do the same with our next one. We're going to graph the parent linear function again. And then I'm going to go ahead and pick some values for x. So I'm going to use the same values of -2, 0, and 1. And -2 minus 2 is -4. 0 minus 2 is -2. And 1 minus 2 is -1. So let's go ahead and plot all three of those points. And then I can draw my line with my ruler. And as you can see this time, horizontally, the parent linear function was translated 2 units to the right. So that's what I'm going to write. G of x translated the parent function 2 units to the right, or I can say right 2 units. Now, you might come across an example where you have multiple translations, and this is where you would be combining both vertical and horizontal translations. Okay, so in our example, like we've done before, we're going to start by graphing the parent linear function, so f of x, and then we're going to graph g of x and describe the translation. So notice this time in parentheses I have x minus 6, so that means it's going to go to the right 6. And then when I add 3, that means it's going to go up 3 because it's outside of the parentheses. So when I use those same points, -2, 0, and 1, so let's plug them in. -2 minus 6 is -8, plus 3 is -5. 0 minus 6 is -6, plus 3 is -3. And then 1 minus 5 is -5, plus 3 is -2. So there's my 3 points. Let's go ahead and plot all 3 of them now and use our ruler to draw our line. And there we go. And now, as you can see, this line has moved the parent function to the right 6, and then it's gone up 3. Okay, so that's what we're going to write down, that g of x translated the parent function, which we know is f of x, 6 units to the right, and then also 3 units up. All right, let's go ahead and perform another transformation. This is a vertical dilation, and this is where g of x is equal to some number a times x. So that number, when I take the absolute value, if it's greater than 1, this is going to give us what we call a vertical stretch, and this is going to be away from the x-axis. So the line is going to be looking a lot steeper going away from the x-axis. If the absolute value of a is between 0 and 1, then we call it a vertical compression, and this is going to be toward the x-axis. So it's kind of like the line is going to be leaning toward the x-axis, like it's going to be getting flat. So here's the parent function. Let's go ahead and choose those same values for x of -2, 0, and 1. And 2 times -2 is -4, 0 times 2 is 0, and 1 times 2 is 2. So there are my 3 points that I'm going to plot. And notice this. The line that's connected by those 3 points is much steeper than the line of the parent function. And notice how it is going away from the x-axis. It's getting closer to the y-axis, actually. So what we're going to write down is that g of x is a vertical stretch of the parent function, which means that it is moving away from the x-axis, okay? And as I said before, the slope here is getting much steeper when compared to the parent function. All right, let's go ahead and look at our second example here. I'm going to draw that parent function, and then I'm going to choose those same points of -2, 0, and 1. And 1/2 of -2 is -1. 0 times 1/2 is 0, and 1 times 1/2 is just 1/2. So I can plot all 3 of those points there, and when I connect those points, notice how this line is actually lower than the parent function. It kind of looks like it's falling down almost flat. So it's getting closer to the x-axis. And so we're going to write that this function g of x is a vertical compression of the parent function, which means that it is getting closer to the x-axis. And if you're just looking at the slope of it, the slope is less steep than the slope of the parent function. Moving on now to a horizontal dilation, again it seems kind of similar to a vertical dilation, but this time g of x is equal to a times x, and that's inside of the parentheses. So now the absolute value of a, when it's greater than 1, this is going to give us a horizontal compression of the parent function, and this is going to be toward the y-axis this time. If the absolute value of a is in between 0 and 1, then it's going to give us a horizontal stretch away from the y-axis. Okay? So, the first example, we're going to go ahead and plot the parent function, and then we're going to choose those same values for my x's of -2, 0, and 1, and a fourth of -2 is -1/2, a fourth of 0 is 0, and a fourth of 1 is 1/4. So I'm going to plot all three of those points there, and look at that. I have a straight line going through the origin, and this time notice that my line is going away from the y-axis, okay? So this time I would say that g of x is a horizontal stretch of the parent function, and it's going away from the y-axis, okay? And if you're just looking at the slope of this one, it is going to be less steep than the slope of the parent function, okay? Because it kind of looks like it is falling down. All right, my next example, g of x is equal to parentheses 3 times x. So there's my parent function, and to plot my g of x, I'm going to use the same 3 points, -2, 0, and 1. 3 times -2 is -6, 3 times 0 is 0, and 3 times 1 is 3. So I can go ahead and plot all three of those points and connect my line. There we go. That's the best that I can do with this small graph. And notice this time it is definitely a lot steeper, but it is going toward the y-axis. So this means that g of x is a horizontal compression of the parent function. So it's going toward the y-axis, so it's a compression, okay? And I could just check out the slope, and you can see that the slope is definitely steeper than the parent function. So now we're going to go on to our last transformation, which is a reflection. First, we're going to begin with reflections across the x-axis. And if I was going to visualize what this would look like, it would be the graph of negative f of x. So everything would kind of be in reverse. So what we're going to do is we're going to first plot the parent function, and I'm going to do that right here. And then we're going to go ahead and plot g of x. But it doesn't really look like what I wrote up above. So how can I rewrite it? Well, this is -1 times 1/2 times x. And notice that we learned this already, that the 1/2 times x would be a vertical dilation. So it's kind of like I'm going to make the reflection of a vertical dilation. So let's plug in those same three values. -1/2 times -2 is +1. -1/2 times 0 is 0. And -1/2 times 1 is -1/2. So let's plot all three of those points, and then use our ruler to draw our line. And notice how this line is going completely opposite from the parent. Okay, it's going downward instead of upward, and there is my x-axis there. And so what I'm going to write down is that g of x is a reflection of the parent linear function, so that's f of x, but it's also compressed vertically across the x-axis. So it's a lot to take in, okay? So take detailed notes on this, and it'll help you out. Let's go ahead and look at now reflections across the y-axis. It's kind of similar. Again, we're going to be looking at the graph of g of x, but this time it's going to be the function when I plug in negative x. So there's my original function, f of x, and g of x this time, if I was going to rewrite this, then I would say that g of x is equal to, inside of the parentheses, -1 times 3 times x. So that 3 times x we learned before is a horizontal dilation. Okay, so it's basically I'm going to perform a horizontal dilation and then I'm going to reflect it across the y-axis. Okay, so I'm going to use those same points, -2, 0, and 1. And when I plug them in, -3 times -2 is 6, -3 times 0 is 0, and -3 times 1 is -3. So let's go ahead and plot all 3 of those points now and connect them with my ruler. There we go. So again, it is going in the opposite direction, and this was reflected across the y-axis, and that horizontal dilation compressed it horizontally. So I'm going to write down that g of x is a reflection of the parent linear function, just like we wrote before, and it is also compressed horizontally, this time across the y-axis. And that's it. So I know that there was a whole bunch that we learned in this lesson about all different types of transformations and how to describe their graphs, but please let me know if you have any questions when you come into class.